This logging device is an acoustic tool. It transmits acoustic energy into the formation, traveling as elastic waves from the point of origin at the transmitter to the point of measurement at the receiver. Acoustic logging operation follows a certain methodology. First, a transmitter initiates the compressional wave that passes through the mud into the bore wall. The wavefront encounters the bore wall at a critical refraction angle, moves along the wall, and sends more compressional waves back into the mud. This returning wave is measured by a receiver, and the travel time from source to receiver is determined.
Typically, receivers are in pairs, so that the time taken by the acoustical wave to pass through the mud from the source to the receivers is effectively subtracted out by determining the arrival time difference between the two receivers.
As we have seen with many logging devices, when the spacing between the source and the receiver is increased, the depth of investigation is increased. Using this principle, long-spaced acoustic devices obtain travel time measurements for undamaged and unaltered formation beyond the bore wall.
The capability exists to record waveforms and identify the arrivals of compression, shear, and Stoneleigh waves, and to measure their transit times. These data can be stacked together and give an interpretable impression of bore wall conditions. In addition, manipulation makes it possible to measure beyond casing with the acoustic sonic technique. For example, this log uses acoustic energy to determine the effectiveness of a casing bond.
There are other general uses of acoustic tools, such as calibrating seismic velocity surveys, fracture detection, waveform analysis, overpressure determination, and formation analysis. You should also learn from the manual the limitations of acoustic devices and the problems that may develop with signal detection and unwanted noise detection.
Before moving on, let's understand that acoustical sonic devices are time measurements between events. These devices do not have calibrations like other logging tools, but engineers frequently make a record of stable, repeatable events, such as uncemented casing that reads a constant value.